Before I talked about regular one-sample z-tests, and now I'm going to talk about how to do a one-sample z-test for a proportion. Now first of all, remember the empirical rule. We know what probabilities are associated with the different areas of the graph. Basically, we know that most of the values, about 95% of them, are going to fall within 2 standard deviations of the mean. Anything outside of that is much more unlikely to happen. And we're going to use that information to make some kind of conclusion with this z-test. But first of all, our question. A survey claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. To test this claim, a random sample of 100 doctors is obtained. Of these 100 doctors, 82 indicate that they recommend aspirin. Is this claim accurate? Use alpha 0.05. So the initial claim is that 9 out of 10 doctors recommend aspirin. We took a sample, 82 out of 100 recommended aspirin. So we're going to say, okay, is that 9 out of 10 doctors recommend aspirin claim really true? Now, realize, like I said before, that most things are expected to gravitate towards the mean. We would expect, in this case, our mean would be 0.90 because 9 out of 10 doctors. So we would expect our population mean, proportion mean, to be close to 0.90. That would be the most common event, the most likely event. If it's further away, then we can say, okay, this is strange. It's not where we expected it to be. So this sample that we took is probably different from the population value we expected to find. Now, see that we are dealing with 9 out of 10 doctors. That's how we know that this isn't a regular z-test. It's actually going to be a proportion because 9 out of 10 is a fraction, it's a proportion, and so on. So we can make a proportion out of that, and we're going to use a different z equation to calculate the z value. It's going to be almost exactly the same with just a slight difference. So first of all, for this question, we have 6 parts. Part 1 is to define the null and the alternative hypotheses. Then we state the alpha, then we state the decision rule, then we calculate the test statistic, and then we state our results and we state our conclusion. It might be different the way you've been taught it. It might be 4 steps or 5 steps or 9 steps. It doesn't really matter. As long as you do these key parts, you'll get the same answer. So step 1 is to define the null and the alternative hypotheses, which is pretty easy. Our null hypothesis is that the population proportion is equal to 0.90. That's 9 out of 10. We're starting off with the assumption that 9 out of 10 doctors recommend aspirin, so that's our null hypothesis. H1, the alternative hypothesis, is that P is not equal to 0.90. We're testing to see if that 9 out of 10 doctors claim is not true. Now, we state our alpha level in the second step, and that's easy because I said use an alpha level of 0.05. Now, the third step is to state the decision rule. So remember, if our alpha is 0.05, and in this case we're doing a two-tailed test, we're looking for the 5% amount of events that are the least likely. And that's going to be split into 2 tails. We have 2.5 on the left and 2.5 on the right. 95% is what's left over in the middle. So if the z that we calculate falls outside of that 95% range, we're going to conclude that it's a strange event and the sample is probably different, so we're going to reject the null hypothesis. Now I have the 2 red lines marked on the graph, and we need to find out what z is associated with those points. And what we're going to do is use the z table. If I have 2.5% in one of the tails, that means I have 97.5% in one of the bodies, well, in the body. So using this table, we find out that the z would be 1.96. And I did that kind of fast because I've already gone over it a few times. If you don't know what I just did, I do have some previous lectures on z-scores and the z-distribution if you want to look at those. But we're going to use 1.96. So the z that we calculate, we expect it to be between negative 1.96 and positive 1.96. If it's outside of that, then it's an unusual event, and we're probably going to reject the null hypothesis. So our decision rule is, if z is less than negative 1.96 or greater than positive 1.96, we will reject the null hypothesis. So step 4 is actually calculating the test statistic, actually calculating the z. And we're going to use this equation right here, where p hat is the proportion that we've calculated from our sample. In this case, it's 82 out of 100, or 0.82. P0 is the population proportion, which is 9 out of 10 doctors, or 0.90. And n is our sample size. In this case, we took a sample of 100 doctors. So all I have to do is plug those things into the equation, and I found out that our calculated z is negative 2.667. I'm going to go to the next page now. If you want to write that down, you can actually pause the video and come back to it when you're done. So now I'm going to state our results. Our decision rule was that if z is less than negative 1.96 or greater than 1.96, we're supposed to reject the null hypothesis. And we found a z that was negative 2.667. Now, as you can see, that's less than negative 1.96. So what we're going to do is reject the null hypothesis. And now we're going to state the conclusion. By rejecting the null hypothesis, what we're saying is that the claim that 9 out of 10 doctors recommend aspirin for their patients is not accurate. That null hypothesis is not true, and the alternative must be. The alternative is that 9 out of 10 is not true. It must be something different. In this case, it looks more like 8 out of 10. That's not exactly true, but that's what it looks like. It's definitely not 9 out of 10. And this thing here, z equals negative 2.667, p is less than 0.05. That's the official format for stating the result. You don't really have to do that unless your teacher asks you to. But just know that that's the answer. We reject the null hypothesis and say that this original 9 out of 10 claim is not accurate at all. So that is the one sample z test for proportions.